Alright, this is lesson 7.6, % problems. I'm not going to do a lot of writing because, but you will. So, % problems, and here's the format for how to do one. When you need to pause it so you can write it down. But we've got % of change, so the actual % in the problem, over 100 is equal to the change in price over the original price. So if something's $40 and now you paid $20, that would go over here. $40 original. The change in price, it went down $20. You can find the % change by putting it in here, and then remember multiplying diagonally to come up with a solution. So let's give you a problem. Fate bought a car at $6,500. The same car costs $7,400 now. What % change is that? So the original price was $6,500. The new price is $7,400. Pause when you need to stop because I'm going to keep going. So remember from the formula that it's change in price. Okay? So not the new price, but the change in price. If you want to find the % change, that's what they're asking for here, okay? % change, that's a big deal. So the % change would be X here. The original price was $6,500, all right? And the change in price we'd have to get from subtracting what it is now from what it was. Okay, so we subtract that and we set that up. All right, and we get 900. Then what we're going to do, we can simplify the fraction by cutting off the zeros. But basically, we're going to cross multiply, so 65 times x equals 100 times 9. Some of you missed this on the quiz. And that would be 900. Divide both sides by 65. So the % change in decimal form is 13.85. Okay, so that will be in percentage. I don't have to change that to a %. That is the %. % increase is 13.85%. Got it? Great. All right, another problem. The Lowe's real estate taxes went from $1,560 to $1,638. What was the % increase? All right, same type of problem. We're going to say % increase is X, that's what we're looking for, over 100. Original price was $1,560. We got to subtract to find the difference, which is 78. We're going to cross multiply. Well, we reduced first, which is what you can do. This is all fine with a calculator, by the way. Okay, so maybe the reducing is not necessary. So we're going to cross multiply and divide. This one happened to work out nicely when we reduce. And for x, 20x equals 100, and x equals 5. So we're going to get a 5% increase. Remember, that is the percentage. All right, a new type of problem. Interest, okay, the amount of money, think of it as when the amount of money that you make. Interest is like the money that you make when you invest something. So if I invest $100, the interest would be that little amount that I earn on top of the 100. That would be sort of considered to be your profit. So how do I get that? Well, it's the amount that it's invested times the interest rate is equal to the interest. So it's always good to think of it in $100 terms. So if I invested $100 and my interest rate was 5%, I'm going to make $5. And when you multiply that out, you'll see that that's how it works. 100 times 0.05 would be $5. All right. So let's look at some problems here that are a little bit more extensive. Emily invested $8,000. Okay, so 8,000 would go right here. Invested in stocks that gave her a total annual income of $550. So she earned $550. So where would that go? It would go interest right here, $550. Now, if part of the stocks pay 8% a year and the remainder pays 6.5 a year, how much money is invested in the stocks at each rate? I'll give you a second to write that down. Pause it if you need to. All right. So she invested $8,000, but it wasn't, the whole 8,000 didn't earn the same percentage. Some earned 8%, some earned 6.5%, and when she was done, she earned $550. So how are we going to set this up? Well, we've got to have two separate problems based off of this right here. The amount invested, interest rate is equal to the interest. Okay, remember that. So we're going to come back, and let's say that X is the amount invested at 8%. Okay, there's two different parts, the part at 8% and the part at 6.5. If that's true, then the money that's left over of the 8,000, all right, would be the part that's invested at 6.5. We don't know what that is. We don't know the X, and therefore we don't know what's invested in each of these, but we can definitely come up with some ideas based off of that. So all I've done here is we're going to make this chart, okay, and what we're going to do is say the amount invested, X, and 8,000 minus X, that's our total amount, at two different interest rates. One's at 0.08, one's at 0.065. These are percentages changed to decimals. And based off the formula, we know we're going to multiply across. So it's going to be 0.08 X and then 0.065 times this right here. So this is the amount of interest that we gain on the 8%. This is the amount of interest that we gain on the 6.5%. And the total amount gained, if we look back in the problem, is $550. So if I add those two pieces together, they should add up to $650. So what I do is come up with this formula. 0.08x is what I got here. This part, interest earned here and interest earned here, should equal 550. Okay? Now these are all these messy decimals, but let's multiply through to get rid of them. All right? Because this is 3 decimal places. This one's 2, this one's not anything. Let's go ahead and multiply through by 1,000. All right, so we can multiply this by 1,000, this by 1,000, and this by 1,000. We should come up with, this is what it looks like. And when we do that, we come up with something like this. All right, let's multiply that 65 part out. Use a calculator is okay, and we get this. Combine our like terms. We get 15x equals 30,000. Divide by 15. And X would equal $2,000. Go back up. Let's look at what X is. X is the amount invested at 8%. So that's 2,000. The amount invested at 6.5%, therefore, is 8,000 minus X, which would be 6,000. The question is, how much money is invested in the stocks at each rate? So the answer, 2,000 and 6,000. Yes, you can do this on your own. Just takes practice. And that's it. So 7.6 is finished. Have those notes ready for me tomorrow.